This is a Triple J podcast.
Hello, welcome back to Science with Dr. Karl. My name is Lucy Smith. This week we were joined by Adrian Brown. If you've been listening to the podcast for a little while, you might remember Adrian. If you've just joined us, well, he's our mate from NASA. He's working on the Mars Rover project, affectionately known as Percy. He gave it that nickname. You'll find out more about that later in the episode. But we like to check in with Adrian to find out what is happening with the Mars Rover project and any feats, discoveries in space exploration, particularly around Mars. You had questions for him about the Mars 2020 rover, about terraforming Mars, and we also got into some really great hypotheticals. I liked this one around, if we really get into traveling to Mars, will our identification one day have to have Earth on it? Could you imagine? New South Wales, postcode, Australia, Earth. Who knows? Let's get into it. Karl, how you feeling?
Very good, because we have a special guest.
Yes, we do. Adrian Brown is with us from NASA. Adrian, a friend of the show, you are back on our shores. Can you tell us what's one thing or a discovery you've made recently with the Mars Rover project that you can reveal?
Well, it's great to be back here, actually. So, the Mars rovers are currently, we're just in the third year of our landing and operations down the surface. And now we've just found what we call leopard spots, which are a little bit like a battery for life. We haven't been able to find them in any other rocks, but in the rocks of the channel going into the delta area is where we've found these really fascinating features that we call leopard spots. We're really excited about those.
So do you know what the function of them is, or is it just the terrain?
Well, if those leopard spots were to appear here on Earth, for example, they'd just be snacked on by any sort of microbes or anything like that. They'd be a tasty snack for life. So potentially, after that time of deposition, then any sort of life on Mars may have been able to use these sort of natural batteries, if you will.
Wow, natural batteries.
Yeah.
Okay. Now, going into this episode, what kind of questions do you reckon you could answer today? What kind of topics?
I think anything about getting humans to Mars as well is really exciting at the moment. We've been seeing some awesome successes from SpaceX in getting the chopsticks, grabbing their spacecraft boosters. That's been absolutely amazing to watch. Really it's a step into science fiction for all of us, I think.
Well, that leads in really well to our first question. Serena in Flagstaff Hill. Serena, what's your question for Adrian?
Hi, doctors. My question is, what is gravity like on Mars? And if humans were to live there, what would be the effects on our bodies?
Yeah, that's a great question. It has been tackled by science fiction, but the gravity is about a third of that of here on Earth. So, yeah, we would probably grow weaker in terms of our physical abilities. And so, yes, Martians of the future are going to have weaker bodies, but they won't need them to get around the planet. They'll probably be all getting around on rovers and drones as well.
What we've been finding on Earth with regard to the International Space Station is that the microgravity, which is effectively zero, has had bad effects upon the astronauts. There's all sorts of things that happen to them. Their eyeballs change shape, their hearts get weaker, their immune system changes. Everything seems to get worse. The thing would be to say that space is a hostile frontier, so we'd need to have advances in biology as well as in space engineering to help people survive on Mars, but at least having a third of a gravity rather than virtually zero would be an advantage.
Okay.
Yes, and it's also about twice the gravity of the moon as well. So you won't be hopping along like the astronauts were. You can pretty much walk a bit like your Matt Damon and not worry too much about the gravity effects.
Thanks, Serena.
Thank you, Serena.
Thank you.
We've got Taylor in Adelaide here. Taylor, what do you want to know?
Morning, doctors. My question is there anywhere on Earth you cannot see the moon?
Whoa, I'm kind of guessing you can see it from the North Pole and the South Pole. It'd be low to the horizon, but there's nowhere where eventually you can't see it. And by the way, just to reinforce everybody's knowledge here, the time that it takes for the moon to go around the Earth is a month. That's how we got that name. So it's not an hour, it's not a day, it's a month. So to answer your question, Dr. Taylor, I think you can see the moon from everywhere. Is you with me on that one, Dr. Adrian?
Yeah. Well, of course, you can't see it from the other side of the Earth, but that varies all the time. So if you just give yourself enough time, the moon will eventually rise.
Yeah, give yourself 12 hours, the Earth will spin underneath the moon.
Yeah. Of course, if you were on the other side of the moon looking at the Earth, that is something that is never going to see the Earth. So on what you might consider the dark side of the moon, it's not actually the dark side of the moon, but it is on the other side of the moon. That side of the moon doesn't face the Earth. So that's a planetary conundrum as to why that actually happens. But yeah, that's
Why we
true.
never see her. It's not fair.
Right. It's also a good place to put radio telescopes because you won't see the interference from the Earth, for example.
Oh, like the light interference.
Right.
Yeah, but in the radio bands, so you'd get a clean signal from outer space.
Wow. All right, we got Brandon in Brisbane
Dr.
here.
Brandon?
Now, Brandon, you got a question as well about sending people to space. What do you want to know?
Yeah, hey doctors. My question is, when we send people to Mars, if we send people to Mars, it's a one-way ticket. So who or what country would get jurisdiction on the planet? And if they do then we have to put Earth as like a place of residence on our passports and licenses now?
Wow.
Yeah, do we need to add Earth after the Australia, for instance?
Yeah, I can relate to that. I'm a dual citizen of the US and Australia as well, so I can add a little personal experience there, I guess. But definitely, Mars is at minimum 8 minutes in timing from us. So that sort of separation is really going to stop communications, natural communications, like face-to-face communications are not going to be possible. So I think that's going to separate Martians just by having that delay. They will have to have their own parliament. They will have to have their own center of power and stuff like that. And that will probably grow over time to be somewhat similar to and different from the Earth, I hope.
However, there is one little catch. If you have happened to have bought a Starlink satellite access and you've signed the contract, which you always do, somewhere around page 300 there's a clause that says that should you decide to go to Mars, that you agree to be bound by the laws of Elon Musk.
Who said that?
It's in the contract. If you have a Starlink access to the internet, in other words, these satellites in orbit, automatically you agree that you will be bound by the laws of Elon Musk if and when you go to Mars.
Okay, so that's who would be running the show.
Well, only if you've bought a Starlink.
Okay.
Otherwise, you're free to obey whoever's there.
We're going to go here to James in St Kilda. James, what do you want to know?
Good morning, doctors.
Good morning, Dr. James.
Good morning, Dr. James.
So, yes, good morning. So 500 years ago, you would board a boat to sail to the horizons unknown with that spirit of adventure. Right? These days, it seems like that kind of adventure is only really going to be attainable through space. So my question is, will it ever be possible for humans to travel intergalactic and engineer the kind of technology that's required to be able to create the sort of energy source that would achieve it?
Okay, I'll start off. We're looking at two things here. Firstly, energy. Secondly, dimensions with regard to doing travel. Energy takes us back to a thing called the Kardashev scale. Kardashev is an astronomer, and he defined civilizations at three levels, 1, 2, and 3. And the number to remember, you're taking notes here, Dr. James?
Yes.
Okay, so remember the numbers 16, 26, and 36. 16, 26, and 36. The amount of energy, the amount of power that the sun throws onto the Earth in a thin pencil beam. So it's throwing power out in all directions, but only a thin pencil beam lands on the Earth, is 10 to the 16 watts. We write down 1 and then 16 zeros, and that's how much power the sun is throwing at us, and we humans will generate that amount of power in around 200 years. Now, 26. The sun throws out 1 followed by 26 zeros of power in all directions, and another 2,500 years after that, we're sort of talking Aristophanes, who proved the Earth was round 2,500 years ago, we will be generating that much power, and then another 2,500 years after that, we'll get to 36 zeros, so 1 followed by 36 zeros. That's the entire power output of every star in our galaxy. So we are heading down this Kardashev pathway, and along the way, the energy sources that we start off with the human labour, the labour of animals, then the labour of fossil fuels, and the energy in one barrel of oil or 200 kilograms of coal is the energy that a labourer puts out in 10 years. And we're going to go beyond the fossil fuels into the nuclear, and then something beyond that. And then the second way of getting around is via the extra dimensions, and we can sort of fold our way from here to there by folding dimensions. And the third way is the ALCUBE. Here's some homework for you, James. Write it down. ALCUBIERRE. And basically what you do, if you want to go from here to London, you shrink the space in front of you and you expand the space behind you, and you can get to London not in a short time, but zero time. Now I've been hypothesising like crazy. Now I'll throw it back to a more reasonable person, Dr. Adrian.
All right, I'll try to be the reasonable voice here. But I would say that, first up, that we have been finding exoplanets in the stars that are close to us. And in fact, the closest star to us, which is only 4 light years away, called Proxima Centauri, is something that would make a great target for humans, the first human voyage out of our solar system. And while it might not be just around the corner, at least that is technologically possible in a future where we'd have very fast rockets. And just remember, once you get that very fast rocket, you do have to slow down as well. So that's going to take a little bit more time as well. But we are actually developing technologies to send drones, if you will, non-human spacecraft out to the Proxima Centauri at the moment. So very exciting.
So time frames, just hypothetically, like what are we saying? I mean, not in our lifetime, surely, but, you know.
Maybe at the end of our lifetime, we might get the technology up for the drone to be going to Proxima Centauri. We definitely have ideas like sending it on the end of a laser ray that would basically accelerate away from the sun, and then you'd use something like the sun, the solar power from the incoming star to slow it down as well. So those technologies are tough.
And Dr. James, you mentioned the word lifetime. In less than a human lifetime, we went from not being able to fly in 1903 into getting to the moon and back. So one person born in 1900 would have seen that happen during their lifetime, and overall around the world, the lifetime expectancy is increasing.
Okay. Thanks, James.
Wonderful, thank you.
We got Jess from Encounter Bay. Now, Jess, you got a little bit of what you've called a darker question. Hit us. What have you got?
Good morning, doctors. So I'm curious as to what happens to organic matter in space, for example, a body in our solar system.
Whoa, just like naked flesh in space. The spacecraft splits open, you're wearing your shirt sleeve type of clothing, no spacesuit, and suddenly you're exposed. I think the first thing is that you would lose your water. Your water makes up about 60% of your water vapour, and I'm kind of guessing, Dr. Adrian, you'd become freeze-dried really rapidly. That unfortunately involves death along the way. And then you'd be pretty well the same indefinitely. And the only thing that could affect you or age the thing that you left behind, your dried out mummy, would be micrometeorites spraying on you and perhaps radiation from the sun.
Radiation was what I was wondering about,
Yeah, the radiation from the sun would eventually heat you up if you couldn't rotate yourself around, like a spacecraft has to rotate around to keep itself cool. So that is definitely a concern. I'm also worried about just the potential of not having or only having a microgravity situation. You might split apart from the inside.
Oh, structural integrity. And the thing is that they did lie to you in that movie Gravity, where Sandra Bullock survives. She comes out of the lake and takes off her spacesuit, and you can see that she's just got skin and her undies on. And what they left out was the roughly 100 metres of hose pipe that carries water to equalise the temperature between the side of the spacesuit that's facing the sun and the other side. So as Dr. Adrian said, you've got to be rotating, because otherwise you're getting one side at plus 200, the other side at minus 200. I'm trying to think what that would do to the biology of the body. I don't know.
Okay.
Turn you in a battery.
Jess, does that give you a little bit of an idea?
It does. I guess we still have a lot of questions to answer about that, which is kind of horrifying to think about. But
but also the possibilities.
Sounds like a great experiment.
Yeah, we got Sachi here. Now, Sachi, what's your question for Adrian and Dr. Karl?
Hello. My question is, why are black holes black exactly? Because if you've ever seen like a video of an explosion, it's usually like red and orange.
They're not
And
really
isn't black holes like stars exploded?
Yes. So what happens in a normal star is you have the nuclear fires pushing outwards and gravity sucking in. And a black hole is what happens when you have a star which starts off being, at the end of its life, maybe 10 times the mass of the sun, and it shrinks. And it shrinks down to a white dwarf, 14,000 kilometres across, a neutron star, 20 kilometres across, and then down to a black hole which is zero. Now, the reason they call it black is that if you have a black hole which has, let me emphasise this again, zero size, it will not emit light, and if any light falls on it, it will not reflect the light. So in that sense, it is black. Secondly, you've got the gravitational effect where it bends the light from stars around it, and then suddenly you're seeing around the black hole, you're seeing curved light, and you're seeing weird effects. Watch the videos Veritasium. Derek Mueller has done a wonderful one on our Event Horizon telescope, had a look at black holes and saw that there was a curvature of the light from distant stars behind it. It's a complicated explanation. I had to watch it twice to understand it, but I'd highly recommend that. So they're not really black. And the third way they're not really black is stuff tries to fall into it, and once it falls in, it's gone, as far as we're concerned. But it can't fall in at the same time. And it runs into each other, and it gives off X-rays. And we have found bursts of cosmic jets, not just kilometres long, not just light years, hundreds of thousands of light years.
Wow.
Like the diameter of our galaxy coming out of the north and south ends of a spinning black hole. So they're not truly black, Dr. Sachi.
We've got Adrian Brown with us from NASA. A lot of questions coming through on 0439 757 555, particularly about Mars. Now, Adrian is working on the Mars Rover project. Can you remind us the nickname that you gave the rover?
So, yes, it's an Australian shortening of the name Perseverance, and we shorten it down to Percy.
Percy.
So it's fantastic.
Yep. Because that's what we do, you know? That's too hard to say. You just got to say Percy.
Right.
And they've taken to it, haven't they?
Absolutely, yeah. The team all use that now, so... Yep. That Australianism lives on
so
forever.
Good. Well, Maddie, in Hobart, you've got a question about Mars. What are you envisioning here?
Hi, doctors. So I've been one of those people who play games like Universe Sandbox and whatnot where you can terraform other planets. I'm just wondering if there's a way we could actually do that to terraform Mars to make it like an Earth 2.0.
Absolutely. Thanks for the question, Dr. Maddie. That is exactly what I would like to see happen to get the Martian planet surface to something about similar in terms of the atmosphere of Mars. So at the moment, we have about 1% of the atmosphere of the Earth on the surface of Mars. But in order to thicken it, we need to get some critical elements. We call them volatiles, like water ice, for example. We have plenty of water ice found on Mars in the polar regions. You could heat those polar regions up, and then the water ice would go into the atmosphere, and it would thicken over time. And so, sadly, we've been doing a very similar sort of job here on Earth. We're now experts at climate change and thickening our own atmosphere and heating ourselves up here. But that's exactly what Mars would need to make it more habitable for humans. And so, yeah, I'm looking forward to that terraforming process to be working for good on Mars.
Okay. Dr. Karl, anything to add? No? All right. Thanks, Maddie. We've got Sean in Adelaide here. Dr. Sean, what's your question?
Hey, beautiful people. I'm just wondering, is it possible to bring back any rocks from Mars back to Earth?
You read my mind. That is an awesome question. So the Mars 2020 rover is currently sampling rocks from the surface, and we consider ourselves the first element of the Mars sample return mission. So we're trying to get those samples that we have in the back of the rover right back to our laboratories here on Earth, where we can do far more advanced experiments on them. We'll be able to do things like date the rocks that we get back, things that we just can't do on Mars, for example, with the rover. And so, yes, we do want to get them back. It is going to take some extra technology that NASA hasn't done before. And so we're currently in the process of making some key decisions on how that's going to happen. Things like launching the samples off the surface. That's probably the hardest thing that we haven't done before on another planetary body. But yeah, that's what NASA's for. We're here to hit the envelope and really advance everything for humankind, I guess.
And what could those rocks look like?
Right. So they're about the size of your finger, so about 5 centimeters in length. And yeah, and we seal them inside the rover so that they don't get lost or interfered with or accidentally come unstuck, for example. That would be a bad day. So we also have to design them so that they don't interact with each other. And also if they have any microbes on board them from Mars, we want to be able to preserve that life as well. So that really involves taking care of them and treating them with kid gloves. Yeah.
So being very careful with them, not touching them. Yeah. Okay. Thanks,
Cool.
Sean.
Thank you.
And we've got Sarah in Newcastle here. Sarah and Ella, you've got a question.
Hey, doctors. Yeah, it's Sarah. I'm asking on behalf of my daughter Ella, who's at school today. Mm-hmm. She has been wondering, what would Earth be like without our atmosphere that we have?
Dr. Adrian.
Right. So this is a great question too, because an Earth without an atmosphere is actually exactly what Mars is today. So I was just mentioning that Mars has a 1% of the atmosphere on Earth. And so why is that important? Well, we need to be able to have an atmosphere to breathe. So without an atmosphere here on Earth, we would be not able to live here, basically, because you need that atmosphere to breathe the oxygen in that you need to get into your lungs. Dr. Karl's the expert on that. Mm-hmm. So then, but also we need nutrients from the atmosphere, and we also need to hold our body together as well. So essentially the atmosphere helps us in all those different ways. And so that's also why we want to change the atmosphere on Mars to something more like what we have on the Earth today.
So what would the terrain be like on Earth without an atmosphere? Would it be similar to Mars, or would we be really cold, or what?
Another great question. So the situation on Mars at the moment is that we have no liquid water on Mars at the moment. We only have ice water at the moment on Mars because the atmosphere isn't thick enough to make the lakes that we have on Earth stable. So that's why we have no liquid water on Mars today, because the atmosphere isn't thick enough to make them stable. So that's what would happen on Earth as well.
So no oceans.
We didn't have the atmosphere that we have today, all of the lakes would disappear, all our oceans would disappear as well.
Wow.
No.
We'd probably still have tectonic plate activity happening because the core of the Earth is hot due to the radioactive decay of uranium, potassium, and thorium, and that heat transfers up into the mantle, and so the molten rock hits the bottom of the tectonic plates and makes them move across. But to some degree, that's affected by water, and the water would evaporate. I think the current figure is that we're losing 90,000 tonnes of gas a year, but we're gaining 50,000 tonnes of meteors a year, so we're overall losing mass, and we'd lose the weight of the water, and that might affect tectonic plate activity.
Okay. Thanks, Sarah.
Wow. Thank you.
And thanks, Ella, for the question. 043975 7555 is where you can send yours in. Bryce in Belgrave, before we get to a break. Bryce, what do you want to know?
My question is, on the rovers on Mars, more the recent ones, what sort of sensor arrays have they got? Are they able to analyse rock samples? And how do you make that so power efficient it can run off the small power sources they have?
Dr. Bryce, this is exactly my day job, to run these sensors on Mars. So yes, we have the latest sensors on the Mars 2020 rover that I'm helping NASA out with. And essentially we have about 9 different sensor systems. For example, we have a big eye system that's actually 2 cameras. That's called a Z camera or Z camera if you're in Canada, for example. And then we have the SuperCam, which has a laser that it shoots at the rocks, heats the rocks up, and looks at what they give off in terms of fluorescence, and then tells us what the elements on the rock are. So those sorts of sensors are really carefully protected on the rover, and we need to be able to look at the surface in as high resolution as possible. So we have these cameras on the end of the rover arm that we can extend down and take images of the surface, very high resolution images of the surface, when we're very interested in the rocks as geologists, to try and find out what the rocks are made of, how big the grains are, those sort of questions.
And I've just looked up Perseverance, and it turns out that it weighs just over a tonne, 1,000 kilograms. And
the Mars rover.
Mars rover. And it's got 6-wheel drive, and here it says that the nuclear power pack has a power output of 110 watts, which is like one of those really old light bulbs. So it's got to save its power so it can travel. Can it walk and talk at the same time? Or has it got enough power to move and also do all the science, or does it normally do one or the other? Because you've only got 110 watts. That's not a lot.
Well, right. And that's our daily allowance, if you will. So overnight we'll get more power back into the rover. But yes, we do have the power to walk and talk at the same time. But we often will have a period where we just want to go. And they have the ability to just travel, say, kilometres at the click of a mouse, if you will, because the rover has the smarts to be able to work out what's the best path, optimal path for us to take. Is there any dangerous dunes, for example, in the way? And it can make those decisions on Mars, which speeds things up remarkably.
How big is the rover?
Yeah, so it's about the size of a Mini Cooper. Oh. Yeah, it's pretty good.
And it's
pretty
1,000 tonnes.
Yes, 1 tonne. 1 tonne.
1 tonne.
Sorry, I lied. My bad.
Okay,
No,
you said 1,000.
I lied.
1,000 watts for the power source.
Oh.
No, hang on. 100 watts for the power, 1,000 kilograms
Thanks,
for the
Dr.
weight,
Karl.
or 1 tonne. Sorry, I've been confusing things. My bad.
No, that's okay. I'm just imagining this little Wall-E character kind of going around. But
it's bigger than Wall-E.
Yeah, she's bigger. Okay, thanks, Bryce.
Thank you, Dr. Bryce.
Thank you.
We've got Ruben in Foster here. Ruben, you've actually got a bit of a career-based question for Adrian.
Yeah, hi doctors. Thanks for taking my call. I'm an aerospace systems engineering graduate and always had a passion for space, and I would love to hear about your career pathway, Adrian, as an Australian working at NASA. I know you said you had a dual citizenship, but I guess how can young Australians who are passionate about space get involved in Mars-based projects and space projects in general, or even access the job market internationally?
Dr. Ruben, that's an awesome question, and thanks very much for asking that. So essentially, there is a space market that's really going off right now with relation to SpaceX. They are going to be launching a factor of 10 more rocketry up into space, and that really requires more humans to be up in space too, and they've been practicing that as well. And now, for engineers in Australia who might be interested in participating in that, we do have a space program now in Australia, which is definitely a foot forward that wasn't around when I was back doing my PhD 20 years ago. So that is an excellent thing to investigate, whether there might be opportunities in Australia if you're interested in staying here. Or you could go to the US, and I actually did what's called a NASA postdoc, and those postdocs are available for anyone who's done a PhD here in Australia, and NASA was paying my way to live over there, and eventually I got to work on working at the SETI Institute and at the NASA Ames Center for astrobiology, and also eventually I moved, after staying there for 10 years, across to the DC area, Washington, DC, and that's where I took up this job that I currently have as the Mars 2020 Deputy Program Scientist.
Wow.
Yeah.
That's so cool. Thanks
in a
for that.
nutshell.
Yeah. So your advice is to potentially see what you need to do here in Australia to then potentially get involved in those programs in the US.
Exactly. And I just want to say that it sounds pretty simple when you say it now, but each step of the way has setbacks and stuff like that. So, inevitably we're going to have setbacks and be prepared for that. It's a tough job market, I know. But I would say keep your back up. Never give up, if you will, on the job that you see yourself doing in the future, because it definitely is out there and waiting for you.
Alison in Tassie, what do you want to know?
Oh, g'day, doctors. Dr. Al here from Tassie. I want to know how those peeps who are up there and were trapped on the space station are going.
Yes, they're doing great, actually. So, yes, we do have 2 extra passengers on the ISS at the moment. In fact, one of them has been made the commander of the spaceship, so she's doing pretty well. And yeah, they're both going well, and they've now been they've been sent up a return rocket, but we just have to wait till February to get that return rocket back in the normal way of things for NASA, because they have other people who need to do science experiments and stuff like that. And can I also do just a little shout out, because I was on Tuesday at a school in Casula area, and they were actually responsible for an experiment that was sent up in our latest refueling mission to the ISS. They'll be having their experiment carried out by the astronauts up there. Really exciting stuff.
What was the experiment?
They're growing algae, actually, under specific lighting conditions and stuff like that. Awesome stuff.
Wow. We actually got a question in on the text line, 0439 757 555. What are the chances of bringing something back from Mars that could create a scenario as in doomsday movies with a bacterial or virus escapee?
Yeah, that's an absolutely crucial question too, because, that's... we have what we call forward and backward contamination. So essentially we need to be careful that we don't sneeze on the samples or the rovers that we send to Mars, because we could be sending COVID to the surface of Mars and detecting our COVID when we're actually trying to look for Martian life on the surface of Mars. That's forward contamination. That's bad for our science purposes. Now, for our civilization purposes, there's also the possibility that there could be microbes on Mars that might be detrimental to our civilization, i.e., something like a Martian COVID. And nobody wants to deal with a Martian COVID, basically. So we want to make sure that our samples are free from those sort of substances or microbes. So we actually had plans, or we do still have plans, to put them in a facility that will lock them up, essentially like the Apollo astronauts were stolen away in a caravan for several days before they could be okay to go out in society, and they didn't have a moon's virus or anything like that. So we'll do the same thing with the sample returns that we get back.
That's great. We've got Dudley in Inverell here. Dudley, what's your question?
Yeah, g'day, doctors. I was just wondering, how they had the laser pointers at the planes and stuff and was affecting the pilots. Could you make one big enough to shoot out into space and just go forever, and if there was alien life, they could see it and go, oh, where's that coming from?
Sure. We do it several times a day, but mainly to measure the distance between the Earth and the Moon. The early astronauts in 1969 left behind some retro reflectors. They're a corner cube reflector. Look up that specific phrase. So light comes out the way it went in. And so a few telescopes running backwards shoot a laser beam to the Moon several times a day. And we measure the distance, and we've worked out that it's moving away from the Earth at 4 meters per century. Now, with regard to contacting other civilizations, basically we just have to aim it at where a star will be when the beam gets there. So if you're aiming at a star 4 light years away, you have to work out where the star will be in 4 years and aim it at that point. And sure, we can do it. And we did it with the Arecibo, big radio telescope about half a century ago, where we sent out a beam saying, hi, here we are. We haven't really done much of that recently.
Yeah, absolutely, yes. And taking it to the laser wavelengths, so the visible wavelengths, is different from the radio signals that we'd be sending out. The light from our eyes would actually be blocked by our dust around us in the form of our Milky Way galaxy has a lot of dust around us. So eventually that light from the visible will be blocked And essentially that's why we see the emu's outline in the Milky Way today is because of the light blocking the stars that are close to us.
So in fact, a laser not in a visible light band, like a maze, a microwave or something like that would be preferable.
Yes, exactly, yeah.
Dudley,
Right,
thanks
yeah.
so much for your question.
No worries. Thank you.
Thank you so much. All right. So, Adrian, what is coming up for you? Where can we check out some of the work that you're doing?
Oh, right. So you can look at Mars sample return missions from looking at Mars 2020. If you go to Google and ask for Mars 2020, and if you're interested a little bit more in what I'm interested in, then you can also check out my website at Adrian Brown, NASA or something like that. The Mars sample return, watch this space. It's going to be new soon.
Fabulous. Adrian, we love checking in with you. Thank you so much for joining us for this episode. Dr. Karl, I'll catch you next week.
Peachy keen.
And that's it. Thanks so much for listening to this episode of Science with Dr. Karl. If you want more from Adrian Brown, if you want to go on that journey with him, these discoveries with the Mars Rover project, feel free to dip into the archives. Of course, we've got more about space exploration as well. We chatted to Australia's first female astronaut earlier in the year. So much for you to listen back to. Make sure you liked, subscribed, and feel free to leave us a review. If you are on a platform that allows you to give us a few stars, we do love to see it. My name's Lucy Smith. This episode was produced by Sarah Harvey, and we'll catch you next week. See you!
Dave Marchese here from the Triple J Hack team. Hey, if you love Dr. Karl's podcast like I do, you might enjoy the Hack podcast as well. Each day we bring you the news that matters to you, from the latest science on climate change to what's happening in politics and news around the world. The Hack podcast. It's your daily fix of the news you need to know. Get it wherever you're listening now.